Hi, I'm Dr. Sheila John, serving as the head of the Department of Costume Design and Fashion in Bishop Appasamy College of Arts and Science, Coimbatore, South India. I'm here to talk to you about the role of computers in the garment manufacture. I am proud to tell you that India is the second largest manufacturer of garments in the world. At the national level, Indian garment industry serves not just the local market but also the export market. It contributes a major share of revenue to the Indian economy and also generate employment to many skilled and unskilled sectors. It constitutes of textile mills, garment manufacturing industries, processing units, fashion designers, wholesalers and retailers. At the end of this module, you will gain knowledge about the significant role of computerized machines in the garment manufacture. You will also gain knowledge on the functions of computerized control machines, specifically fabric inspection machine, spreading machine, cutting machine, sewing machine, computer control color matching system and the embroidery machine. First, we will learn about the functioning of the fabric inspection machine. In a garment unit, manufacturing process starts with the inspection of fabric. The fabric is the base of the garment and it may have defects. If this defect is not identified now, it will become a garment which will be rejected as a defective piece in a later stage. This will also become a great loss to the manufacturer. In this process, defects are identified and the defects are corrected or eliminated based on its nature. In the computer controlled fabric inspection machine, the fabric is unrolled and passed over an illuminated sensor and it ultimately gets rolled onto another beam. During this process, the sensors identify the defects and stops the machine. The operator notes the defect position and mark it as X. During the spreading process, this portion is removed with the splice point. Certain model of spreading machine has inbuilt fabric inspection machines. The fabric defects are checked as they are being spread. At the end of the process, this machine generates a report with a list of defects. It also tells us the length and width of the fabric roll taken for the production. In the sampling section, the pattern making, grading and marker planning is done using the pattern making software. Using the CAD software, the patterns are prepared and the printout of the pattern in its full size is taken in a plotter. The plotter is nothing but a large scale printer which prints out the pattern in its full size. The patterns thus created are graded for different sizes using the same software. Marker planning is another important step which gives an economic layout. The economic layout helps in reduction of fabric, thus bringing down the manufacturing cost. The marker plan is created for a combination of sizes and the same is loaded in the computerized cutting machine directly. The marker plan need not be in the printed format when the cutting is done in a computerized cutting machine, because the computerized cutting machine does not need a reference for cutting. If the cutting is done manually, the marker plan can be printed out in full size and placed over the top of the layer for the cutting master to view. Now we shall learn about the computerized spreading machine. Spreading or laying is a process where a piece of fabric is carried from one end of the spread to a specific length. The first end of the fabric is aligned and placed at one end of the table and the remaining fabric is pushed to the other end. When it reaches a specified length, the fabric is cut. This process is repeated for many times. So we see that the fabric is laid one over the other. The number of layers of fabric is decided by the number of cut pieces required, the thickness of the fabric and the blade height of the cutting machine. The computerized cutting machine can be preset to a number of layers. The machine will emit audible signal when it has reached the set number or when it has come to the end of the fabric. Turntable device is also available, which is used for a face-to-face spread. When a fabric roll is finished, the auto lifter in the machine transfers the empty bar and lifts the next available roll of fabric to the machine. Some machines have inbuilt sensors which detects flaws and damages marked during the inspection process. These defects, once sensed, are cut by the ply cutter and a splice is made in that particular position. Thus, we can note that it can also do the function of a fabric inspection machine. All the activities of the manual spreading machine are programmed in the microprocessor, and then therefore the machine works automatically. The spreading process is a laborious process, and thanks to the computerized spreading machine, the process is made simpler. Next, we will move on to the computerized cutting machine. These machines are faster and are more precise in cutting layers of fabric. The cutting surface of the table has nylon bristles which are flexible. This nylon bristles supports the lay and keeps the lay in place. The flexibility in the nylon bristles also permits the penetration and movement of air between the cutting blades. The bristles allow the passage of air through the table to create a vacuum. The vacuum thus created reduces the height of the lay and holds the fabric in place. The cutting head in the carriage has two synchronized motors which drives the machines to and fro. The carriage moves on rail track which is positioned on the sides of the table. A third motor positions the cutting head on the table. These two movements are coordinated to give the knife a position on any point of the table. The cutting head consists of a knife, automatic sharpener and a motor. The motor rotates and positions the knife on the lay and cuts the fabric to the shape of the pattern as dictated by the marker plan. The sharpener sharpens the cutting blade at regular intervals. This cutting machine does the functions of a straight knife cutting machine, band knife cutting machine, notcher and drills, and this is definitely a cutting edge in the garment manufacture. Since the computer controlled knife cuts according to the instructions from the computer rather than following the pattern lines on the marker, it is possible to remove the printing of the marker plan. Now we shall learn about the computer controlled sewing machine. The clothing industry is dominated by a number of varied models of sewing machines, and the automation of sewing machine is advancing day by day. Automation is a process by which the processing of a product with little or human intervention. Automation in sewing machines is advantageous for the following reasons. For the first is the monotony. The monotony in the operation causes fatigue, and this is reduced or sometimes even eliminated by the automation. The cost of the labor is also greatly reduced. The efficiency in production is increased, and therefore the quality of the product is improved. Automation in sewing machines includes automatic foot lifting, automatic backtracking and stitch counting. To name a few disadvantages of the sewing machine automation, we can say there exist numerous variations in textile structure which makes it difficult to handle for the machine and also for programming for various textures. The changes in the fashion leads to newer styles day in and day out, and the silhouettes makes the production sequence also complicated. Automation may lead to unemployment, particularly in the developing countries like India. This may be a disadvantage. Machines like buttonhole, bar tacking, button sew, and label machine are simple automatic machines which is controlled by CAM, that is computer aided manufacture. The shape of the sewing line is determined by the machine, hence achieving consistency must still be carried out by the operator in the handling activities both before and after sewing. In a top stitching of a shirt collar, it is possible to program number of stitches to give the correct shape and size. At the end of stitching the collar band, photoelectric or infrared detector stops the machine at the right position with the needle down for long enough for the machine to turn the fabric to another angle. Such sensors can also detect different thicknesses of material, such as thickness between the patch pocket and the garment panel it is being attached. Thus, the machine can be set to stop automatically at the pocket corner for the operator to move the garment around. Also, the activities like raising the presser foot and backtracking at the end of the seam can be programmed with the microprocessor control machine along the needle positioning and thread cutting. The operator has to perform the initial operations only, like positioning the fabric under the presser foot and removing the fabric from the presser foot. Fully automatic sewing equipment have been developed for assembling the types of garments which are made in larger quantities with a minimum style change, but the only condition is it has to be in a flat state. These garments are primarily shirts and men's jackets and trousers. In formal shirts, the top stitching of a collar and cuff or label attachment to a yoke or yoke attachment to the body and patch pocket attachment are some of the common automation cycles. In men's jackets and trousers, the main opportunities for automation are in the construction of welt and flap pockets and also in the serging and joining of leg panels. Now that we've seen the computerized sewing machines, we'll move on to the computerized labeling machine. The labeling process is used as an alternative to the elimination of printing the marker plan on the top ply for the computerized cutting process. The labels have adhesives on the non-printed side of the labels. This gives the necessary information that aids in bundling. The information includes the name of the pattern and the size codes. This helps in cost reduction and also saves the printing time. This system is mounted over the lay of fabric where the beam travels along the table. A label dispenser also travels with the beam, which gives position to the label placement. Some label dispenser also print label during positioning. Otherwise, the labels are printed separately and loaded into the dispenser. The process of positioning is faster if the dispenser is loaded with printed labels. The computerized color matching system is another machine which aids in shade matching of fabric. It is a boon to the colorist and the textile scientist. Color matching requires two important steps. The first is careful laboratory dyeing of each dye steps in 4 concentrations on substrate such as nylon, tricot, polyester knits or wool carpet. And the second step is measuring the reflections of characteristics of these dyeing using a spectrophotometer. This is done at different wavelengths in the visible spectrum. The reflection values can be measured by the spectrometer and the values can be stored in the computer. Computer programs are available for checking and calibration data, which helps to pinpoint errors in measurements, recording the reflectance values. This is done before the color matching is started. The color matching system permits the dyer to call for 2, 3, 4 or 5 dye combinations. The result of a computer-aided color matching operation is usually a theoretical recipe. The calculations are based on the characteristics of a dyestuff and the assumption that the individual relationship of the absorption of the dyes and the concentration are valid when the dyestuffs are mixed together. Computer color matching systems can do the prediction of color matching, color difference calculations, and it can also determine metamerism. Color fastness rating is also possible with color matching systems. It can also work out the cost comparison, strength evaluation of dyes, and the whiteness index. The advantages of the computer color matching system has in the textile industries are as follows. The customer gets the exact shade, and the customer has the choice of 10 to 12 recipes that will match the color, and also he can check the cost and the availability of dyes and the auxiliaries. It is 300 times faster than the manual color matching. It can also maximize the first time dyeing to be correct. One can also make economic recipes, and this can also help in minimizing the lead time and production loads. This will ultimately maximize the profit. Now we also can see the web-based color matching system, which is a modern concept that has been a great advantage to the colorist, whether they are in the small scale sector or a large scale sector. Color matching is done online, where the image of the fabric swatch is submitted and the report is received in a short period of time. The primary function of this application is to provide recipes for shade matching and the color difference. This also has some advantages. The speed of the application is much faster as this works on the internet. The client need not worry about the system breakdown, bug fixing, maintenance, etc. The cost is also subsidized because it is only a one-time application. Last, we will learn about the computerized embroidery machines. As we all know, embroidery is a surface decoration applied in a fabric or garment which adds value to the product. Traditionally, embroidery is made in hand, which involved artisans with artistic skills, and also it takes a longer time to complete. Later, the embroidery machines were developed which had a set number of stitches which varied in length and width. This reduces the time of production, but still it called for a skill on the part of the embroiderer. But with the advent of computerized machine, the commercial production is made easier and cheaper. It can embroider up to 12 samples at a time, and it takes only a few minutes for the design to be embroidered. The following are the steps involved in the computerized embroidery machines for creating an embroidery design. One is the creation of embroidery design, and another one is loading the embroidery design in the machine, positioning of the fabric in the machine, and finally the embroidering of the machine. Designs can be created in many ways. It can be done manually by an individual designer, or it can be purchased in the formats that will suit the machine. If a design is created manually, it can be transferred into the computer through the digitizer. Designs that are created in the system should anyway suit the appropriate software. This CAD designs also help the designer to edit the designs by cropping, scaling, rotating, moving, copying, pasting, stretching, or distorting the designs. Many color schemes can be created before a design is finalized. Thus, different machines require different formats, and the most common formats are PES, and there are also other design formats like PES, VIP, JEF, HUS, and so on. The embroidery patterns are thus loaded into the embroidery machines through the floppy disk or CDs or pen drives. The fabric is positioned in the embroidery machine after the fabric is being placed on a frame. The frame offers stability to the fabric. Certain types of fabrics require an additional stabilizer to keep the fabric firm. These stabilizers are backup fabrics which are laid under the fabric or on top of the fabric. Stabilizer includes cutaway, tearaway, vinyl, nylons, water soluble, heat and gone, peel and stick, and open mesh types. Embroidery is done with the embroidery head, and the number of heads in the machine varies from 1 to 56. After the fabric is hooped, it is fixed into the machine. The machine is threaded with embroidery threads of prescribed color. Some machines may have single needle and some may have multi needles. Once the machine is switched on, all the machine heads starts to stitch the designs at the same time, and the process needs only monitoring. The advantages can be listed as follows. The designs are made faster and easier. It can be stored for a longer period of time and can be reused whenever needed. The space needed for the physical storage can be eliminated. The thick and thin fabrics can be embroidered with the same ease. The stitch speed and capacity can be increased. Special applications like attaching the beads, appliques, quills also can be an additional feature. The quality of stitching is very high and it is ideal for commercial use. The garment industry and technology is growing in leaps and bounds, and the recent garments include seamless garments, where the garments are created in the knitting machine itself. It is also widely acknowledged that computers have an inevitable place in the industry. The computer control machines, as we saw, help in increased production and qualities. As designers, it is a must that we should learn about the eminent place of the computers in the garment manufacturing sectors. God bless you. Have a nice day.